Well, hello, friends and followers. Here's something I've been working on for the past 2 days. It's been my desire to get this Ten Tec Pegasus that is now under the table. It's been fixed, it's working, and I have it connected up to my Mac. So this is an iMac running, and I have it going in through an FDTI cable, which is right here, into the Mac. On the Mac, I'm running a Python program which I've written, and I did borrow parts of it from a guy that wrote some stuff for a RX 320 Ten Tec, and I've modified it greatly. But basically, this program will run a thread which will talk ASCII to the Pegasus, and there is an ASCII document here, if I can find it, that describes how to talk to the Pegasus, which they nicely wrote back in, 1998 or something. So anyway, this Pegasus has had a Windows-based program that ran on XP and on Windows 2000 and on 98, and they updated it to work on Windows 10, and it does work on Windows 10 and 7 and 8, but I wanted to get something working on the web so that I could remote this transceiver someday, and I've made some progress. So right now I have a couple of REST APIs that'll talk to this thing. I can return this index page here, which isn't very impressive yet, but I'm just starting this, get the S meter, set the frequency. So I spent a lot of time today getting the keypad to work. So I just got this frequency display to work, and that looks wrong, doesn't it? I'm not sure why it says that. There it is. That's weird. Okay, I guess it's right. Okay, so I can twiddle the knob here, the optical encoder, and it will change the frequency now on the web of my Ten Tec Pegasus, which I'm really happy about. That took a lot of work to make that happen, but it's happening. So that took a heck of a lot of work, but it is working now. And I also got the keypad to work. So I like to do things like, if I want to go to 10 megahertz, I just want to type in 10. That's it. I don't want to mess around. So if I want to go to 5 megahertz, I want to type in 5. So 5, enter. That throws me on the 5 megahertz right there. If I want to go 1 megahertz broadcast band, type in a 1. And that takes me right there. Then of course I can tune around and get some AM stations. And if I want to get specific, I want to say go like to 3885. I would type in 3.885, enter, and it didn't work. I still got bugs. I'll try it again. 3.885, enter. The second time it works, so obviously I got a bug somewhere, but that's where the AM guys hang out, and the program might have blown up because my encoder now is not working. Can I change anything now? Nope. So the program blew. It ate its lunch here, I think. Something blew up or not. Yeah, it's still running. I'm not sure what happened to it. Anyway, to restart this program, I just go like this. I end it in Eclipse and I restart it. There, now it's running again, and it defaults to 10 megahertz. So I probably got some bugs in here somewhere. It didn't like that frequency, but it's working again. So anyway, and they say this thing lags. With me, I have the Python code where it's not lagging at all. And the trick is, when you tune, you want to turn off the S meter, so there's no S meter readings. That makes the tune work really well. Otherwise, the Pegasus is too loaded down processing ASCII data. So I got to put like a decimal point like 5.1 in here or something. Got to fix that. But this is my preliminary adventure with this stuff. So it tracks really well. I'm really happy with it. Just diddling along here. Oh, let's see, type in like 15.123. And that didn't work. Did it blow it up? It's working, but not right. Try it again. 15.123, enter. Nope, that didn't work. So I got some problems there. I thought I fixed that. Type in 15.1. Nope. It still tracks though. I got some work to do, huh? How about 15.123? That should work. And it did. So I gotta fix the decimal point, but it looks like it'll take a frequency like that. How about, let's see, 1, 5, 1, 2, 3, 4, 5, 6, enter. Yep, it does that, so. But then I got a bad offset in there, huh? Go back to 15 even. So yeah, so I'm making progress to this thing. I gotta get all the other, I gotta make a decent web page for it now and get everything automated. This is my first attempt. I think the hardest thing to do was get the frequencies to change, so I'm really happy about this. So here's some AM stations for SWL around here. Let's see what I can find around here. Let's see. There's usually AM on here at night. So anyway, I got to get all the mode stuff on here, all the different things that a Pegasus and a Jupiter should do on this web page, and get it all set up. Make a nice, slick web page for it. That would get me the frequency control and the control of the transceiver. I still wouldn't be able to process audio. I need some other path for audio, but this is a start, so it's what I'm doing. One of the hardest things today about this was getting binary data figured out. 2's complement data from the encoder. That was not sure what that is. That was painful. Anyway, so there we go. And it tracks pretty good. I mean, I can really thrash this thing back and forth, and it obeys. So I'm happy about that. Anyway, so programmatically, this took me hours to figure out one stupid thing here with this thing, in that if I can find the document for this thing, let me try and find the document in my downloads here. Of course, it's not easy to find. Looking for it. Nope, can't find it. There it is. All right, I must have closed this thing. So the encoder operation of the Pegasus. This gets rough, but as you can see here, this has a high byte of movement, a low byte, and a key code. I'm not using the key code, but it's kind of nasty. So the trick is getting this thing into a BCD. Well, actually, the trick is combining these two bytes together into a 16-bit, because here it has a high byte and a low byte. And so you combine these in the 16 bits, and then you have to do a 2's complement on it. So how did that happen in Python? Let me show you here. That happened. Here's some of the web stuff that as it wants frequency, it's just pulling. I have it pulling from the browser side. And let me see if I can find this thing here. So when it comes up, I just set all this stuff up like that. And the encoder part was nasty, if I can find it. So I have it running in a big loop right now. Here it is. So this was nasty. So if I get an exclamation point, that means it is a frequency function from the wheel. So the first thing I do is I pack this thing into a 16-bit structure, I guess, using the struct pack, and take it as 2 bytes, and I put in the 2 parts of that buffer. This took me like hours to figure this out. Crazy. And then you have to go int from bytes, and you're going to go big endian, and then a 2's complement on it. And I think somebody wrote a procedure that I borrowed to get that to work. And then finally I will add that to the frequency with the step, and then set the frequency, and that's how it tunes. So it wasn't that hard looking, but it wasn't easy. So yeah, this took me hours. So that thing up there, 2's complement, some guy wrote that, and I found it on, yeah, here it is. This worked out rather well. So there was probably 20 discussions on how to do this, and I guess I learned about this stuff from college again, which I had forgotten about. But anyway, yep, this is all it took, was that and that. But all day to figure that out. That's how it goes. Okay, well, I hope you enjoyed my demo. You can see it's trucking along here. And yep, so I just got this working. The web page only has one field, which is a frequency, and I figured it was important to show the frequency change. Now I got to make like a nice, radiator looking thing with dials and all that, and put buttons on for changing things and get it working. But this was a start in how to do it. And get the encoder to work here. Half the fun is the encoder, actually. I mean, you gotta admit, this thing's fun. There's AM band here. So anyway. So now, now I gotta make up a cool web page for this thing that looks like a radio and is really, really snazzy. That is gonna take some time. All right, well, thanks for watching. Have a great day. We'll see you later.